Matrix factorization sees a bag of clicks, not their order. RecBole's SASRec uses self-attention over the sequence to predict the next item. Then we verify the gain with recall at 10 and NDCG at 10. You'll rank the next item from click sequences using SASRec with causal masking and benchmark against a pop baseline with recall at 10 and NDCG at 10. I'm Professor Pi, teaching AI foundations with simple Python. Sequential recommendation solves a plain practical problem. Real users browse in order. Today's click matters because it follows earlier pages. Models that ignore order can miss common patterns. Quick compares, then a purchase. SASRec learns those left-to-right signals with self-attention, so it can pick the next likely item from a short history instead of relying on overall popularity. Think of a session as a short story. Each item is a sentence. SASRec reads them in order and leans on the most relevant earlier line when guessing the next one. That makes it strong where recent context predicts intent. It's less helpful with brand new users or when popularity completely dominates behavior. We'll run a compact end-to-end experiment. The plan: create a tiny ordered click file RecBole can read, convert it into the SASRec dataset, run a popularity baseline, then train SASRec and compare recall at 10 and NDCG at 10 on the same leave last split. That tells us whether sequence modeling actually adds value. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we need a tiny click file that expresses order and fits RecBole expectations, so we can inspect the sequence behavior before training. This snippet writes a tiny ordered click stream that RecBole can read. Matrix factorization would treat these as user item events, but the key signal here is the left to right path: home, product detail, cart, accessory, buy, review. The .inter file uses RecBole atomic column headers with user ID, item ID, and timestamp. The toy paths are small enough to inspect on screen, while still having more than 10 item candidates. So recall at 10 is not automatically perfect. The printed count confirms that the dataset has real rows ready for the next step. With raw clicks in place, RecBole needs to know which columns matter and how long a history to keep. So we prepare a dataset object for sequence modeling. This example turns the raw click file into a RecBole dataset for SASRec. The important move is not training yet. It is telling RecBole which column is time, which field holds items, and how long a recent history can be with max item list length. Create dataset, config, reads tinyclicks.inter, and prepares RecBole's internal token IDs, including padding IDs used by sequence models. Keeping train neg sample args as none matches SASRec's cross-entropy setup. The printed users and items show that RecBole has converted readable tokens into a model-ready catalog. Before training, we must confirm how examples look for sequence supervision, so we split and peek at a batch to verify prefix target structure. This code asks RecBole to split the dataset and then peeks at one training batch. Sequential recommendation is supervised by prefix target examples. Item ID list is the visible history, and item ID is the next click to predict. Data preparation, config, dataset, applies the chronological sequence handling configured earlier, so the model learns from ordered prefixes instead of unordered baskets. Field to ID token maps RecBole's internal IDs back to item names, which makes the batch easy to sanity check. The output shows one concrete history and its next item, proving the learning target is sequence aware. To judge whether sequence modeling really helps, we need a fair baseline that ignores order but faces the same test split. This example creates the comparison point before giving SASRec credit. RecBole's Run RecBole runs pop, a popularity baseline that ignores the click order and recommends broadly common items. The eval CFG still uses time-ordered leave-last style splitting, full ranking, recall, and NDCG at 10. So the baseline faces the same next item test that SASRec will face. That matters because a weak split can make a sequential model look useful when it is only seeing popularity. The output gives the baseline popular recall 10, the number SASRec must beat, or at least explain. Finally, we train SASRec on the same data and report the two metrics so we can compare directly to pop. This snippet finishes the mini-experiment by trading RecBole's SASRec on the same data and split. The SASRec config keeps the model intentionally small, but it still uses self-attention over item ID list, with causal sequence modeling handled inside the RecBole SASRec implementation. Epochs controls how many passes the model gets over these prefix target examples. Increasing it can help fit patterns, but on tiny data, it can also overfit quickly. The final calculation subtracts pop's recall at 10 from SASRec's recall at 10, and also reports NDCG at 10. The output shows whether sequence order improved retrieval, and whether the relevant item moved higher in the ranking. Applied to a production log, this tiny flow maps directly. Replace the toy.inter file with real session logs. Raise max item list length to keep longer histories. And scale batch sizes and epochs. The evaluation stays the same, so reported gains are comparable. What this showed in 3 quick points. SASRec is a sequence model that uses self-attention over item histories to predict the next item. Use it when order matters and the recent path signals intent more than raw popularity. One caution: on very small or extremely sparse logs, SASRec can overfit and may not beat a simple popularity baseline. A practical next step is to increase max item list length when you move to longer session logs and rerun the experiment on the same split to see if longer context raises recall at 10 and NDCG at 10. If learning practical recommendation models in Python helps, subscribe and watch the AI Foundations videos.